So welcome to lecture 16 of MCS 260. In the 8-week summer session, this is the second part of session 8 in the 8-week summer session, finishing off 3 of the 8 weeks. So we're close to halfway in this course. In some sense, if we distinguish between programming in the small and programming in the large, then we have essentially seen already all the tools to write small programs. In this lecture, I will indicate how we can work with files directly, not via a DBM file, and also how functions are typically collected into modules. So we are still doing programming in the small, but we can nevertheless, if we work with modules, write already very large programs, or at least very useful programs. And again, this is another illustration of top-down organization, but where modules are also used to hide information. So if you are managing data, you have to decide on the format in the data. So all functions that deal with a specific file format or a specific format of the data are grouped into the same module. All right, let's go through the slides. Files. Why files? When we run a program, its data is in main memory called random access memory, which is quick to access, but the data that's in main memory disappears after the program terminates, and certainly vanishes when you shut down the computer. But files offer permanent storage, so we distinguish between memory and storage. This is computer science terminology, so memory is not like memory like we humans have. The files that we are going to consider today will be readable text files. This also includes our .py files, also is our notebook files. They're all text files, but we will not be treating those files. We will just take text files. Text files are readable, even though the formatting is often not intended for human consumption. Binary files are only readable for the computer, an executable, for example. The advantage of files, permanent storage. So if you have a very long running program, it might be good to actually write some data to file. One has to keep in mind that access to files on disk drives is slower. It's certainly slower if you would write it to, say, here, this memory stick. And also that buffering is used. When you open a file for writing, if you write something small to it, then it will appear only on file physically. You can look at it when the file is closed. It's good to think as files, although we don't really use tapes anymore, but it's still good to think of them as tapes which are sequentially organized. So in order to get to, so that is actually another reason why files are so much slower than random access memory. And perhaps now it's also clear what the term random access means. In main memory, every element can be accessed via an address, and that given that address, it doesn't really matter where the item resides in main memory. This is not the case on file. If it is at the end of the file or the middle of the file or the beginning of the file, it actually matters. So if you want to insert an item in a text file, you actually have to shift everything to accommodate space for that new item. So appending to a file is much more natural. Files are organized in directories. We also call them folders. In the time of search engines, this might not seem to be so uh, useful anymore, but we are computer scientists. We are organizing data, and it's good practice to have at least some organization on your disk. So for this course, I organize all the files in separate folders, lecture per lecture. Every file has a name, but it also has kind of an absolute path name. And this is important if you're going to access files outside the current folder you're working in. Files have modes. If you list in a file listing, so if you do ls, and ls works in the PowerShell, in Python it also works on Unix, you will see some letters in front of it. So a directory or a folder is actually also a file, but it's a special file, so it has a special mode. We have executable files. On Linux, you have the executable mode. On Windows works with the extension. So you have the .exe extension, which is a binary file, an executable file. A file can be listed as read-only, especially in a multi-user system. You may not have access to, or you may not have the privileges as a simple user to change certain files. Okay, so here is the running example. We have seen the top-down design. I call it here a top-down functional design. We will later see object-oriented design. Here we are going to have just strings that we manipulate. Every string contains information about a book, and we are writing a very simple library manager. So here are the functions. We can show the collection, we can add a new book, we can check a book out, check a book in. So every book is stored with an extra flag, whether it is available for checkout, or whether it is checked out. So there will be two modules. One bottom At the bottom we will have a module that will define how the books, as we see them, the information that we want to store, how that is mapped into strings. So modules are being used to group functions that are concerned with the same problem. So how do you represent the information of a book as a string? Here it is. The layout of a book. We could say that we represent a book as a tuple. The first bit, or first is a boolean, true or false, available or not. Then every book has a unique number. Its key in the dictionary and also in the database terminology. And then from a book we will only store its title. So it's an exercise to store a lot more. We have two books for this course, so I should pull them up, bring them up again. So there is the Python book, Programming in Context, And there is the other book, and I opened them up today. So I was fiddling with my lectures, and I was consulting them. So I do have the two paper copies. So just since everything is online these days, and there are still actual paper books that are very useful, at least for people from my generation. I'm using columns to separate the entries. In some sense, it's a little bit idiosyncratic. It's a little bit unusual, perhaps, but it illustrates the flexibility that we have when we start manipulating our own text files. A more common format would be the comma separated value file. We will see some file processing later, or perhaps not, or there might be a project on file processing. Comma separated files for Python, they're not any different than if you use any other separator. So the split and the join are again useful operations in processing strings. Okay, I just say that there will be a file, books.txt. Um, I'm now running this on a Windows computer, and actually I prefer also now having the explicit extension, so we're dealing with text files. Um, on Linux and Macs, if there is no extension, then it is a text file. Okay, modules. We encountered modules before. We used the mat module, we used the random module. So in strictly speaking, it is a component of a software system. So if you want to define a software system, a software consists of a collection of modules, and then you define the relationship between the modules. So we see modules before objects. A module can also contain the definition of a class. But every module has an interface and a body. The interface is what you see when you type help and then the name of the uh, module. So in some sense, again, writing good documentation strings is an important skill to have. The body is called the implementation. That is what the functions or what the module does. So it what realizes the functionality. We import a module exports resources. So you can also export a list. So we have seen that the system module, the sys module, not the system module, the sys module exports the list path. And that list path, so you can look it up in an earlier lecture, this path is going to define the order of folders where the Python interpreter will look in order to find the modules that you import. So you can write your own mat module. Perhaps that's not so wise to do, or if you're really ambitious, perhaps it is. But your own mat module could then overshadow the mat module of the Python library. In general, everything what you need to import is actually not part of the standard library. So comes kind of uh, additional comes by additional software. So a lot of the what comes with the modules that come with Python are often written also as well in Python. Here is something what we have covered before. So you can import the name of a module, import mat, and then you have to, when you want something to you want to use something from the mat module, you have to explicitly list that you are applying, say, the square root function. from the mat module. Why is that good? Well, there are many other packages like NumPy, for example, will also provide you with a square root. There is SymPy for symbolic computation that will also provide you with a square root. So you can rename. I have given examples of that. From mat import square root as my square root, perhaps not a good name, as dmat square root. So you can rename things. Now it's important when you do the importing of a function such as from mat import square root, that will be the square root in your Python program. Help is useful. To quickly see what is inside the module, do dir, obtain the directory listing. So that gives you everything that is in there. Often very useful. We use that on the list to see all the methods that you can apply, all the operations that you can apply to lists. Okay, files now. A file has a name. In order to work with this, you have to open the file. And what you get is a handle onto the file. So it's an object, so a file object. So every file object has methods that you can apply to the file. When opening a file, it's very important that you know what you're going to do with the file. Are you going to open it for reading, or are you going to open it for appending? If you write to a file, you actually make a new file. So it's very important that you realize what you want to do. You may not want, so especially with the W option, you may want to check first if there is not already a file already there. And that could be a practice if you write a program that asks a user to give the name of an output file, that you first check whether that output file already exists or not, and that you then ask to confirm the user, hey, do you want to overwrite this file? There is a reason why some files are read-only. Okay, working with files, you can read or write. So here are the basic commands. You can read line by line. You can also read a certain amount of characters first. I have not listed it here. I'm just assuming that, and I'm perhaps a little bit old-fashioned with this, that when you work with text files, that every line has a proper ending. So I view a file, a text file, as a sequence of lines. And I'm actually a little bit confirmed in this with the read line and the write lines. So you can read all the lines from file all at once. That gives you a list of strings. So again, this could be very useful to everything again with list comprehensions. That was what we talked about in the first part. There is no write line because to a string you can always append a new line. So in some sense, you can, I mean, I would not, so you could still have output files that are text-based, but that are actually not really meant for human consumption. So you can actually write character by character or strings, string after string, and you can also read a number of characters. You can read character by character, say if you process a comma separated value file, you read until the next comma. Um, Closing a file is always good practice. Notice that closing a file means that you close the file object. There is a distinction, I should probably have emphasized this. There is a distinction between the actual file with the name, so the books.txt, and then the variable f, the variable which refers to the file object used to manipulate the actual text on file. So there is again a layer in between the actual characters on file and what you use to manipulate the file object. Okay, um, there is one running example. So I mentioned the empty file. So in some sense, this is a good utility to have. So you can check whether a file exists or not by opening it for reading and see whether the file is there or not. It could be that empty file. So empty file is here whether the file exists or not. I think if the file does not exist, you may have an exception handler. So here we just check whether the file is empty or not. There is one application, the Simple Library Manager. I will show this program in the last part of the lecture, and most of the exercises are actually dealing with extending this application, quote unquote. So this is already a larger program. In this course, we see only small programs because it's an introductory course. But nevertheless, you can have your program that is now spread out over several files. Um, that is also important, an important realization. So there is sequentially searching through. So you can do this actually with a list comprehension. So you read all the lines and then you do the in method. So in some sense, with a list comprehension, 5 is almost 2 lines long. You can also do it line by line. So that's more the conventional list processing. The last exercise, deleting a book, is actually you can requires that you essentially reorganize the content of the file. So if you really want to remove it from the book, you could of course change the identification number and make it to something that is negative to indicate when the identification is negative, it's a non-existing book. But then here, the number itself, a negative number occupies a little bit more space in the file. So you may have to make a copy of your books that doesn't contain that one single line that contains the book. Again, this could be the best solution, and again work with list comprehension, read lines, and then remove one line from one index so you can delete from a list. We have seen this, and do the right lines then. So that would be the cleanest solution. Cleanest in the sense that a solution that is short and therefore also easy to verify its correctness. So in this course, we are primarily concerned whether a solution is correct or not. Okay, I have prepared a Jupyter notebook. Once I was saying that if I give a demonstration, it's something that I know, that every programmer should know without looking it up. But here I have perhaps too much to show, just to do an interactive demonstration. Okay, perhaps now it's a really good way to show the entire the entire Jupyter Lab environment. You see that I have the files, but then I also have the books there. So I have already made a file that contains the books. So I start from that perspective, from the common perspective that you work with existing files. Um, I will illustrate how to make files. So you can actually, and that's actually a very good exercise to, if you do not have this file books, you could make it with the operations from the Jupyter notebook. We open a book for reading. So I call it lib because it's our library of two books. And here you see two books, The Art and Craft of Computing and Making Use of Python. So these are two books that I was using, and I still have them, that I was using in earlier runs of the course. So the current books that we are using are a little bit more modern and up to date. Uh, so I call it lib. Lib is the name of the variable, so I can name it anything. On the other hand, the arguments of open, they are not arbitrary. So I have given the uh, name of the file because I'm working in the current folder. In the current folder is important. Otherwise, I need to give the complete path name if it's somewhere else, or a path name that's relative to the current folder. I open for a reading, and then I'll read all the lines, and I show all the lines here. It's good. So now I'm at the end of the file. I want to illustrate how to read line by line. You see the new lines are indicated. So these are strings as well. So I do this, so that's perhaps also a reason why I'm scrolling through this, because I'm lucky here there's only two lines. But if I do this 3 times, you see that at the end I have an empty string. So the read line will actually always succeed. It may be that you don't get anything at the end, and that's also the test that is used to check if you read a file in a script line by line. If the line that you have been reading is the empty string, then you break out of the loop. So this is another good illustration of the break. All right, I was saying that it's good practice if you work with text files just to have new lines, and by default you would have lines of 80 characters long, although I'm also now currently violating a little bit when I work at computers with a high screen resolution. But you can, if there are no new lines, or if you want to read character by character until you meet a colon or a comma or whatever character you're looking for, then actually you can apply the read. The read has as parameter the number of characters. And I see here that I was reading and not closing. So here I'm opening it again. So it's no harm if you read, but it's actually bad practice not to close a file if you are no longer using it. So there are, and that's in the last part, I will show also how Python actually, how you should open a file in a code block. So there is the with construction, with open, a little bit, but I'm racing ahead of myself now. Let me continue. So writing to a file. So I'm going to write now a file new books with the books that we are currently using. So I have here the book Computer Science an Overview. So that's the book that I have. And this is actually recommended, so it's optional. But if you want to have another second opinion, and if you like reading books, then this is recommended. So here I'm only storing that the book is available. And in my new books, this is the first book that I'm adding. So this is a great book on computer literacy. Notice the W. So I have already done this, so it's already in file, but it will overwrite this. So here it is important that I close, or perhaps I could, not sure if I can show this. Yes, I can. So if I open for writing, so I just executed it. Now I go to, and I do an ls. So a wildcard is good. You see my new books has 0 characters in it. My other books had 60 characters in it. So the wildcard is very useful here. So let me go back to the Jupyter notebook. Now I'm going to make the string. It's a book. And I'm going to write following by the new line. So it's good that I'm executing this anew. So you see I haven't yet done the close. So let me go back, and I'm waiting a little bit. So you see that I can still wait a little bit. The computer is not doing anything because for 36 characters, 36 bytes, it doesn't really bother to write it. So this could be very inconvenient. So especially if so files are also being used to communicate between programs. So you have one program that is using the file as an input, and that file is written by another program. It's important that the buffering, the flushing of the buffers is happening. So the buffers are flushed here, and I can check this. You see, I can also do a more. So this will also work on a Linux workstation. You see, I have the computer science and overview, and then the new line. It actually, when I do more, it actually shows also the new line. So you can think there are 2 lines on there. All right, our first write was a success. So let us now do the append. So it would be wrong to write again because that would start a new file. So this is to illustrate the other mode, other access mode, you are going to append to the file books. So I was mentioning that files are sequential, and that might have raised some alarms. But if you are using a file sequentially, always appending to it, then the open for appending actually goes very quick. And also appending just a new line, provided that you are not against the disk limit and that you don't have too much disk fragmentation on your computer. If you have still plenty of disk space available, adding a new line is not any harder than writing a line. Okay, I have my new book. That's the book I wrote. Again, I have to show it. So this is this book. Of course, it is in physical presentation. So my new book, it takes 35 characters, but again, to make the point, if I do more new books, nothing has changed. And you can wait and wait and wait and do no more new books. Uh, it's not going to change because I haven't closed the file. So I close the file, and actually, I should emphasize this. In the computer program, I can also check into this. So this is an illustration how a code cell, it's good practice to have many statements on one line. Okay, also illustrating you don't need to use always the same name of the variable. All right. Very good. I still have 15 minutes left, so the timing of my pre-recordings gets better and better. Let me point out at the scripts that I have provided. So here is the main program. So I have a simple library manager that consists of two files, two modules. I have the module BK form that will deal with the formatting of a book, the information about the book on as a string. You see, this is a program with a main at the very bottom, but you can already see what it's a simple terminal-based program that displays the menu right from the start. Um, and that menu is already, in some sense, it's good that it becomes in front of the file. It gives an accurate description of the actions that you can do. Typically, this would be running in a loop. So I should say that if this is really true. So here is the main program. So we prompt for a choice. If the choice is 0, I break out of the loop. So that's again an illustration of the break. And why it's actually quite good to have this break statement. So then we have the different menu options, four of them. It could be that the user mistyped. Um, depending on the choice, we will call a particular function. Um, and this is the top-down design. So I have now one function. If you design, so please do not, if you write software, please execute as soon as you have a piece of a function or a piece of a program that does something. So the start of this program would be just to test the showing of the menu and whether the break actually works, whether you have that functionality. Okay, the other important thing is a utility function, the number of books. So how do I do this? Well, we have the read lines. We can count the number of read lines. We open, so here this is important. We open, so in the Jupyter notebook I showed lib equals open, but it's actually much better practice to open with the width. So that means that you have a block. So lib is the file object, and everything that is in the block is using the library. It's also then really good check to see that you really close. It's in a block, but the result is still accessible outside. As you can see, we return the result, but we return the result after closing the file object. So we have the showing of the books. That is again a read line, and that will get the key, get the title, get the status of the book. You see what formatting of the book now does. I defined rather strangely that I'm going to use colons separating and that the fields are going to be in a very particular order. But here I have the get key, get title, and get status. And these are the functions that are exported by the BK form module. So this is kind of a helper function module. So in some sense, these are all helper functions. And they are just a couple of lines long, but they fulfill the important status that if I change the format on file, if I say I'm going to use comma separated value files, the library.py does not need to change. So it also enables pair programming that you have one person focusing on the logic of the menu and the handling of the tasks, and then the other person deals with the formatting. So if you have a key, a title, a status, you can then make your string representation. So that is done here. Packing. What the pack does, the pack will add, so it's being used adding a book. When you add a book, you will only be prompted for a title. You don't want that the user is going to know how many books there are already in the collection. So here you see the usefulness of this utility function, the number of books. The number of books will provide the um, index, so the number plus one. Then we have the fact that it is available, the status, and then we have the title. Perhaps I should have worked with keyword arguments here. That might be making it a little bit easier. So then I'm going to append. So I'm going to open the books for appending, calling it lib again, writing that one line, and then closing. Notice by writing here, I'm not adding the new line. It's more than likely that Pack did it, that everything is terminated properly with a new line. Okay, if you want to check out your first one, you don't think that. So this is a small collection, not for a huge collection of, say, hundreds of books. You would just see it scrolling. So it would be good to manage, let's say, a very specialized section of a library that doesn't have more than a dozen books. So when the showing of the books happens, you see actually the showing of the books, and that is actually done in a very nice way. And now actually I should run this program. So let's see, checking out the book. So I'm going to do Python library. Um, I'm going to check out the book. And here you see I have two available, and I can now give so both of them are available, and I can type in 0. 2, I'm going to I'm going to check what is in that making use of Python. The making use of Python, by the way, is available as a free PDF file. It's a Springer book, and you may have to log into our UIC library. So that could have some use still. So if I now want to check out, oops, there is still a bug. So there is an error there. So that is embarrassing. So the art and the it's still available, but then it did something with the get key. So it's an invalid literal. Let's see what has happened there. So make more books. Yes, so it has changed the 1 into a 0. And now I still don't know. Oh, it forgot the call. So you see, it did not put the colon back in. So there is a formatting error in the program. How embarrassing. All right, then let me uh, try to see how which one is actually responsible for this. So there is the so I was checking out the book. So when I check out the book, I should actually pack the 0 and then get the title. So if I so there is a the packing did actually not work. So you see, when I check out a book, I'm going to open for reading to actually show the entire collection. but then I'm going to rewrite every book again. For every book in the collection, if it is, if I have the key, so the key is what I want to check out, I'm going to write the book that is in there. And in some sense here, when it is unavailable, I'm going to write just the book back, just as it was retrieved. Otherwise, I'm going to write the book with the index back, with the status 0 and then the title. And I'm just going to copy in all other cases. So I'm actually rewriting, I'm going to change the file, and this will rewrite the entire collection. Okay, now I'm suspecting now that something went wrong in this pack. So let me go now to the other module. Here is the pack. Um, so if the status is, it will be um, writing the key. Um, the key comes first. Okay, I think there is an and you see there what I forgot. Here is what happened. I know. So I adjusted the program to use a formatting string, but in my haste I forgot the column. So that is the mistake. Um, so the status always comes first and then is the key. Okay, so what I need to do is I need to let me now indeed demonstrate that I fixed this bug. So I will save the Python file, fixed that bug. I will also have to change the data file. So the data file books is actually rather corrupted. Um, I cannot, so I have to open it again now. So let me go to the I'm going to open the text file. So here it is. The text file that I will open is this, and now I have a nice editor sitting in there, and I can insert the column. Saving the text. Um, Perhaps for all, I will get out there and go back to seeing that it is fixed. Okay, let me now illustrate that the rest of the program works. So I will return the book. Return a book to the library. Give the book number. It is making use of Python. And now I can show all the books in the collection. You see that making use of Python is available. I should probably have started with this. But let me now demonstrate that I have fixed the bug. I will check out now again a book, and I should check out the same book. It went well, so let me now show all the books in the collection. Then you see that making use of Python is checked out. So if I want to check out the book again, then it will just list making use of Python is unavailable. Okay, I'm close to the end. I only have 1 minute left. So I hope that I should probably show the rest of the bottom module. The split is very important here. So actually you see the other functions are very straightforward. So it is splitting on that column. If I use a comma instead of a semicolon, I have to change only this file. And I could make this file better by declaring somewhere a separator constant. All right. We have software systems. Softwares or larger programs are always not one single file, but are multiple files. So in a way, we introduced files as text files, but we also have files as code files, the .py files. Okay, so this terminates the third week in our 8-week summer session. We have covered a lot of ground already, and I hope that this is not too confusing and that you can start now writing very interesting programs and have also gained a lot of insight how, as a computer scientist, you can make good use of a computer.